The modern assumption is that refrigeration marked the beginning of reliable food preservation. But, that assumption overlooks something important. Long before electrical grids and compressors existed, societies across Eurasia, North Africa, and the Americas developed methods capable of holding winter ice through the heat of summer. These were not improvised tricks. They were engineered systems maintained by labor structures, taxation, and logistical planning that often paralleled military supply networks. In several regions, ice storage was tied directly to political authority and survival readiness. Armies marched with preserved provisions, urban populations endured heat and disease with cooled supplies, and ruling elites demonstrated control over nature through the distribution of cold. What tends to be missed is that storing ice was not about luxury alone. It reflected disciplined observation of landscape, material science practiced without formal terminology, and the understanding that preparation months in advance could determine resilience when conditions deteriorated. The techniques developed before refrigeration reveal an intellectual tradition of environmental adaptation that later informed both civilian infrastructure and wartime logistics. Examining those methods is not an exercise in nostalgia. It is an opportunity to see how disciplined planning and resource awareness once replaced mechanical dependence. Understanding that ancient ice storage began with controlling heat rather than preserving cold. Ancient builders recognized that ice does not need continuous freezing to survive. It needs insulation from heat transfer. Their approach centered on limiting conduction, convection, and radiation, even if those terms were not formally defined. Subterranean construction was a recurring solution. By placing storage chambers below ground, they exploited the Earth's stable temperature. Soil acts as a thermal buffer, slowing seasonal fluctuations. This principle was widely used in Persia, Rome, China, and later in early modern Europe. The most refined example appears in the Persian yakhchal, structures dating back over 2 millennia. These dome-shaped buildings combined underground pits with thick insulating walls made from a composite mortar, resistant to heat transfer and moisture penetration. Ice harvested during winter or transported from mountains was packed tightly, layered with straw or sawdust, and sealed within the chamber. The geometry of the dome minimized solar exposure, while encouraging airflow patterns that reduced internal warming. These were not isolated experiments. Entire administrative systems governed ice collection and storage, and such infrastructure contributed to urban sustainability in arid climates where temperature extremes threatened both food stability and public health. This principle of controlling heat rather than generating cold echoes in later military encampments, where storage of perishables depended on terrain selection and passive cooling. Commanders who understood environmental moderation could sustain troops longer without resupply, reinforcing how environmental knowledge translated into strategic advantage. Recognizing that ice harvesting itself required planning comparable to logistical mobilization, preserving ice across seasons began with winter harvesting. This process often resembled organized labor mobilization. In northern China, historical records describe teams cutting ice blocks from frozen rivers, transporting them to imperial storage pits, and cataloging reserves for court and medical use. Similar operations existed in Russia and Scandinavia. Ice was not gathered casually. It was cut in standardized blocks, stacked efficiently, and packed with insulating materials to minimize air gaps. These efforts mirror logistical preparation seen in military supply chains. Gathering resources when conditions allowed ensured stability when scarcity emerged. In the 19th century, before mechanical refrigeration, the global ice trade expanded this concept into industrial scale. Harvested ice from North American lakes was shipped worldwide, demonstrating how ancient principles evolved into international commerce. The continuity between ancient and early modern practices shows that disciplined seasonal planning remained essential, even as technology advanced. For survival-focused observers today, the lesson lies in timing and foresight. Resources tied to environmental cycles cannot be secured reactively. They demand anticipation and organized effort well before necessity becomes visible. Seeing how insulation materials revealed practical material science without formal theory. Straw, sawdust, and even wool repeatedly appear in historical accounts of ice storage. These materials trap air pockets that slow heat movement. Their widespread use demonstrates empirical knowledge accumulated through trial and observation. Roman ice houses used compacted snow mixed with organic packing to reduce melting. Medieval European estates refined similar methods, constructing insulated pits lined with timber and earth. This practical material science extended beyond domestic comfort. Armies and settlements required methods for storing perishables, medicines, and sometimes temperature-sensitive supplies. Knowledge of insulation affected everything from winter shelter construction to casualty management in campaigns where exposure and disease posed greater threats than direct combat. By understanding how common materials function thermally, ancient societies maximized limited resources. This reflects a mindset of adaptation rather than consumption. The materials were local, renewable, and replaceable. Their effectiveness came from correct application, not technological complexity. Examining how architecture transformed ice storage into long-term infrastructure. Ice houses became permanent fixtures in many regions. In Britain and continental Europe from the 17th through 19th centuries, estates built brick-lined underground chambers specifically designed for seasonal storage. Entry passages were angled to reduce warm airflow, and drainage systems prevented meltwater accumulation, which accelerates heat transfer. These structures maintained internal temperatures capable of preserving ice for months. In Japan, similar practices existed in feudal domains, where ice stored during winter could be presented ceremonially months later. The act symbolized authority over environment and labor. Infrastructure devoted to ice storage therefore carried political meaning as well as practical utility. The architectural mindset behind these structures parallels fortification design in warfare. Both fields required anticipation of environmental stress, structural resilience, and efficient use of materials. The shared principles reveal how engineering solutions often transcended specific purposes. A society capable of building stable cold storage was also developing competencies applicable to defensive and logistical architecture, considering how cold storage influenced medical and military endurance. Ice had applications beyond food preservation. Ancient and early modern medical practitioners used it to reduce swelling, manage fevers, and preserve certain treatments. During later conflicts, especially before refrigeration, stored ice played roles in casualty care and transport of medical supplies. This connection between seasonal preparation and wartime resilience illustrates how civilian infrastructure quietly supported military endurance. Control over temperature also affected morale and public health. In hot climates, access to cooled water or preserved food could reduce disease spread. Urban populations with functioning storage systems endured summers differently than those without. This had implications for stability, productivity, and resistance to hardship. Military planners learned from these patterns, recognizing that environmental preparation influenced operational effectiveness as much as tactical skill. The broader lesson is that resilience often emerges from systems built long before crisis. The infrastructure of preparedness rarely appears dramatic, but its absence becomes evident under stress. Reflecting on what these methods reveal about discipline and environmental literacy, ancient ice storage demonstrates a mindset grounded in observation and patience. Societies without mechanical refrigeration were not less capable. They simply relied on environmental literacy and collective organization. Their solutions required sustained attention to seasonal rhythms, material properties, and spatial design. These qualities cultivated resilience because they distributed responsibility across communities rather than concentrating it within machines. The transition to electrical refrigeration improved convenience and scale, but also shifted perception. Dependence on continuous energy obscured awareness of passive alternatives. When power systems fail, the historical record reminds us that temperature control once rested on structural foresight and resource management. Those principles remain applicable even if modern contexts differ. Understanding these practices is not about rejecting technology, it is about recognizing continuity in human adaptation. The capacity to moderate environment through planning rather than reaction remains relevant in disaster readiness, expedition planning, and sustainable infrastructure design, closing by recognizing why preserving overlooked knowledge strengthens perspective. Ancient methods of storing ice across seasons reveal more than technical ingenuity. They expose habits of preparation, cooperation, and environmental understanding that supported societies through uncertainty. These methods shaped urban life, informed medical practice, and quietly influenced logistical thinking that later appeared in military doctrine and survival strategy. Their importance lies not in novelty, but in perspective. They remind us that resilience has long depended on disciplined anticipation rather than technological immediacy. Remembering these quieter histories matters because they broaden how endurance and preparedness are understood. They show that stability often rests on systems built patiently and maintained collectively. If this kind of careful, grounded historical analysis is something you value, subscribe to Iron Age Instincts and share this video with others who want to look beyond familiar narratives and examine the foundations that truly sustained human societies.